Hi, welcome to our third and final video for Lesson 4.4 on bivariate distributions of the continuous type. In this video, I'm going to talk about how to calculate covariance, correlation, and the least squares regression line when we're working with bivariate distributions of the continuous type. The covariance, as we can see, is defined the same way that it was with the discrete random variables. It's the expected value of x minus the mean of x times y minus the mean of y. The only difference is that in order to calculate that expected value, instead of summing over all the possible values of x and y, we need to integrate over the support of x and y. Also, the computational formula that the covariance sigma xy is equal to the expected value of xy minus the mean of x times the mean of y still is true when we're working with continuous random variables. And sometimes that's easier to work with computationally than the covariance formula given above. The correlation, rho, is equal to the covariance divided by the standard deviation of x times the standard deviation of y. That definition is exactly the same as the one we had when we were working with discrete random variables. And the equation for the least squares regression line is y equals the mean of y plus the correlation, rho, times the standard deviation of y divided by the standard deviation of x times x minus the mean of x. And this again is exactly the same as what we used when we were working with the discrete random variables. So I'm going to work through an example calculating covariance, correlation, and the least squares regression line. The example I'm going to use is problem number 4.4-14 from the book. Suppose that x and y are two continuous random variables with PDF f of xy equals 8xy, where x is between 0 and y is between x and 1. And if we wanted to show that this is a valid PDF, we can see that it's always positive. The other thing that we'd need to do is we'd need to integrate over this support and show that the area under the surface is equal to 1, which it is. So in order to start calculating covariance, correlation, and the least squares regression line, I'm going to need to calculate the marginal PDFs, means, and variances for x and y first. So I can calculate the marginal distribution of x, f of x, by integrating over all the possible values of y, and y can go from x up to 1, our PDF 8xy dy. And that gives me the marginal distribution, f sub x, of 4x minus 4x cubed. And I can use that to find my mean of x. I'm going to integrate over all the possible values of x, which go from 0 to 1. X times that f sub x. So that ends up being integrating 4x squared minus 4x to the 4th dx from 0 to 1 gives me the mean of x is equal to 8/15. And once again, I can find the variance of x, integrating over all the possible values of x, x minus the mean of x, which I just showed was 8/15 squared, times our marginal distribution of x, 4x minus 4x cubed, dx. And that gives me a variance of 11/225. I'm going to go through this process again with y. My marginal distribution of y, f sub y, is found by integrating over all the possible values of x, which go from 0 to y, 8xy, that's my PDF, dx. And I get a marginal distribution of y of 4y cubed for y between 0 and 1. I can integrate over all the possible values of y times that f sub y to find the mean of y, and that gives me 4/5. And I can find the variance of y which is 2/75. So that's a good start. Now I'm going to start working on my covariance. So the covariance of x and y can be found by integrating over all of the values of x and y. X minus mu sub x times y minus mu sub y times my PDF f of xy. And the reason that I'm doing this is because I'm looking for the expected value of x minus mu x times y minus mu y. Since I'm integrating with respect to y first, y is going to go from x to 1. And then when I integrate with respect to x, I'm going from 0 to 1. Plugging in the values for my example, I'm substituting in 8/15 for mu sub x, 4/5 for mu sub y, and 8xy for our PDF. And it gives me a covariance of 4/225. Now for the correlation, we're going to need to take that covariance that we just calculated and divide it by the standard deviation of x times the standard deviation of y. I just calculated the covariance of x and y is 4/225. The variance of x is 11/225. The variance of y is 2/75. I calculated those before. So substituting into this formula, I get 4/225 divided by the square root of those variances multiplied together. It gives me a correlation of 0.4924, which shows me that I have a moderate positive relationship between these variables. That as x increases, y tends to increase also. And this makes sense because since y has to be greater than x. The last thing we're going to do is calculate the least squares regression line for this distribution. It takes the form y equals the mean of y plus the correlation times sigma y over sigma x times x minus the mean of x. I found all of these pieces previously. Now I just substitute them into my equation and find my least squares regression line is equal to y equals 0.606 plus 0.3637x. I hope it's helpful to work through that example. Have a good day.